In this video, we are going to talk about the column importance feature and properties of models. We will run and test it on the Titanic binary classification model. You can find the Titanic dataset on the First Steps workspace. We can see that we have the Titanic classification binary model here. Let's click on it to get a brief context of the dataset. We are going to predict the survived column, which is a binary classification problem. We will predict whether a passenger survived the accident or not. We can also get an understanding of what each column means and what the goal of our problem is in the What to Do section. Let's now go to My Data. Since our data will mainly focus on the feature importance of the models, we are going to skip the pattern and go directly to the training and model. As we said, we're going to predict the survived column. I have already run a model here, but let's run another model using classification. We may also ignore some columns. We are going to run a fast model that will roughly build a model in a few seconds. We also have advanced options if you want to alter the train and test or optimization metrics. We will add synthetic data to our dataset to generate a more generalized model. Let's now train our model. It will give a model in a few seconds. The results are ready now, and we can see that we have some suggested accuracy models. Our model has 86% accuracy, and we are particularly interested in the column importance. When we are on the column importance plot, we have the available classes here for the 0 class, which means when the passenger did not survive the accident. We can see that males generally contribute much more positively to the passengers who did not survive. That is, if a passenger is male, he is much more likely to not survive the accident compared to females. Similarly, we can click on the one here, which means for the passengers who survived the accident. Females are much more likely to survive the accident, and males contribute negatively to the instances where the passengers survived the accident. You can get similar analysis for other column examples. Let's click on the Age feature and see how age influences the behavior. When the passenger did not survive the accident, as age increases, we generally have a smaller negative impact. That is, children are actually less likely to survive the accident, whereas old people for some reason manage to survive on a better scale compared to the younger people. Similarly, for the passengers who could survive the accident, if the age of a passenger is younger, he actually has a lesser chance of not surviving the accident. That means that our previous analysis was somehow misleading. When the age of the passenger is increasing, he is more likely to not survive the accident. You can get a much clearer picture of this analysis here. For instance, we can see that as the passenger's age gets older, he or she is less likely to survive the accident. You can also hover your mouse on this line to get a much more specific number of the ratio between the passengers who are 10 years old and 4 years old. Let's also click on another feature, Ticket. You can hover your mouse on different available classes to see how they contribute to the chances. We can see that when the class is 1 and the passenger survived the accident, we don't have any significant difference. However, we can see that for the tickets with this number, it actually contributes positively to the 0 class. That means if a passenger has this ticket, he or she is likely to not survive the accident. Whereas if a passenger has tickets on the buttons, he's more likely to survive the accident compared to the passengers with this ticket. Similarly, you can get a similar analysis for other features as well. Don't forget that you can always click on the numbers on the upper section to get the plots for different classes. Since our problem is binary classification, we have 2 different classes. But let's say if you have a classification with 3 features, we will have 3 numbers here that will lead to different plots. We can also see that some of the features on this section add up to what happens. That means you can compare how different features contribute to the final results. We can see that the attribute sex is by far the most influential feature, whereas age, tickets, and parch are not that big of a deal. Sex has 88% importance and is by far the most strong attribute, so you can always compare the contribution of each feature on this column importance graphs. That's all. See you in the next video.